So we're going to talk about the limit of rational functions. The limit of f of x divided by g of x as x approaches a. It's super important to pause and think about these types of functions first. You need to analyze the domain of this function. So make sure to find the domain of the function. The domain of the function is the very first characteristic, the very first property that you need to focus on. Don't skip finding the domain. The domain of a rational function is defined as the set of all x values, real values, such that g of x is not 0. So you're accepting x values, real values, that doesn't make the denominator 0. After analyzing the domain of the function, we're going to divide this up into 3 different cases. In case 1, a is in the domain of the function. Give us an example. In this example, I ask you to find the limit of, let me follow up the note, 3x squared minus 4x divided by 5x cubed minus 36. This is a rational function. What is the domain of this function? The domain of this function, as we know, is all real values like x, such that this guy cannot be 0. So 5x cubed minus 36 is not 0. Or the domain of the function is all values like x, that 5x cubed cannot be 36. You can simplify this. All x values such that x cubed is not 36 over 5, or finally, we can write it as all real values such that x is not the third root of 36 over 5. We can use a calculator to find this number. For now, leave it as it is. We want to find the limit of this function as x approach 2. So basically 2 is not this ugly number. 2 is acceptable in the domain. 2 is in the domain. So this is our very first case. If a is in the domain of the function, we're going to use direct substitution. There. So this limit is equal to 3 times 2 to the power 2 minus 4 times 2 divided by 5 times 2 to the power 3 minus 36. So we have 12 minus 8 divided by 8 times 5, 40 minus 36. So we get 4 divided by 4 or 1. So the limit of this rational function is 1. Again, this is your very first case. A is in the domain of the function, so we're going to use direct substitution.